Welcome to all. Today I am starting analysis of statically determinate pin-jointed plane frames. Sometimes it is called trusses also. We will discuss later. That is analysis by method of joints and method of sections. This method of joints, method of section will come little later. Now, first of all, make a note. This subject, this chapter, that what pin-jointed plane frames, I already told, statically determinate. This usually comes in first year of engineering. When people, because it comes in engineering mechanics, at that time, almost everybody will not be knowing much about this subject or also strength of materials, further subjects, structural analysis, RCC, steel, design subjects, pre-stress concrete, etc. They all will be studying later. Therefore, here I am not going for too much of discussion on the arrangement or how these are constructed. Briefly, I will tell. Because important to understand. So many things, see, I told statically determinate and one more called indeterminate comes. Briefly, I will tell here. I will not discuss too much more. Because later, when you go to structural analysis, you are studying analysis of statically indeterminate pin-jointed plane frames. And you are studying even rigid jointed plane frame also. Space frame, usually people don't study it. Software will take care of it. Then you have to analyze something called indeterminate or some people call redundant frames. I use a word later. At that time, there will be more discussion regarding stability, determinacy, what is determinate, what is indeterminate, much more. And when you go to design subjects like steel structures, there you will be knowing correctly how is the arrangement, see, bridge trusses, roof trusses, that all will come there. And I think somewhere I have seen, they give too much of explanation for these parts, sketches all they will write, etc. One who is studying engineering mechanics in the first year engineering, he can't make out anything. Just he will follow something, that's all. And maybe some people will understand, but majority will not understand anything. Majority what they want is, I will tell you, this one, because as they open question paper, what you can see, using method of joints or using method of sections, they can see questions. So they are more interested in solving. But that does not mean that I can directly give procedure here. This will come. So I will explain not too much. And one more thing, some terms all I will explain. In the board, I will not write like, see, this is called this one, that is called that one. I won't write. I will dictate. Those who want to understand everything, you should make simultaneous notes. Or I already gave the option for you. Notes will be available for you. You can see my earlier uploaded class. In the playlist, you can go and see there. Then there, I will write much more. See what all I explain here. And I write everything because notes you cannot explain. You have to write it. So you can see more explanation there. That is left to your choice. Now, but remember, in case you are studying yourself only, preparing your own notes, you should be very serious and sincere to write everything I explain here. Okay, now I will change over to next part. First, in the beginning, I will tell what is a pin-jointed frame. I won't write on the board, I will just state it. See, a pin-jointed frame, plane frame, is an assembly of members, all members lying in one plane. And connected at the ends, connected or joined at the ends by smooth, either you use a smooth or frictionless hinges. See here, I will tell you how it is. Don't see this one. See, you take for example one member here, one more member here, put a pin, smooth pin. So see, it can rotate. So once again I will tell you, I won't write here. A pin jointed plane frame is an assembly of members. In the bracket you can write all members lying in one plane. Continue. Connected at the ends or joined at the ends by smooth or frictionless hinges. Then what is pin jointed space frame? Same definition, but all members does not lie in one plane randomly. See, one member this way, one member this way, randomly. That is space frame. Space frame we won't discuss here. Only in the notes I will write sketches. Okay, now, therefore, see, these are all sketches I written are pin jointed plane frame. See, all members lying in one plane. One plane, one plane. You can observe one thing here. Everywhere you can see triangles. Nowhere you can see open rectangle. See, you cannot see it. No, this is not there. I will give the reason for that one now. Why triangles are considered, I will tell. First of all, you make all this note first, then you write. When you connect by a pin joint, see, it is like this. I will go for basic arrangement. See, the most stable arrangement in simple form is this way, is a triangle. A triangle is formed. Triangle formed. I will give a small example for you. Suppose you got a table, only two legs, it will be unstable. If four legs are there, it will be stable, no doubt. But even then, see, it can wobble. But three legs is the most stable, or you go for tripod. See, there is a tripod here. You have seen tripod. See, I don't know how to put sketches all. See, usually for mounting cameras, this is a tripod. This everybody knows what is tripod. Here, tripod has got three legs. See, suppose you want to make a shooting somewhere using camera mounted on a tripod. Two legs you can't imagine. Okay, four legs, it is very difficult to put the tripod. See, two legs is unstable. Four legs, it can be stable, but very difficult to align it. When you align this way, that will come out. When you align these three, that will come out. But three legs, very easy, just to put anywhere you want. That's all. It will automatically take care. See, you can have different of elevation, nothing. So remember, basic form, the most stable arrangement, simple form is triangle. That is the basic form. Basic form. Like your figure 1. See here. Figure 1. See here, I'll put here. Figure 1. See here. This is, you always show, like, see, this is some people, they told, see, same structure, they may like this in examination solve. See, they give like this. Support we will discuss later. This all I will tell you later. Okay, now. This way question will be given. But even if given like this, it is understood that, see, even if the question is like this, I will always write, see how I will write this one, how I will write. because it is a pin jointed frame. See here, I will always write like this. Then I will show the support. This way, see? Triangle. Now, you keep on adding triangle. That's all. See, here, already one triangle is there. Second triangle added. Third triangle added. Here, see, 1 minute. I'll first explain. I will put other way. Okay. Here, see, this support, leave it now. Here, see, one basic form triangle. One more triangle added. One more triangle added. One more triangle added. That way, add triangles. Again, it is stable only. Now, some by chance, see here, after adding this way, I will put extra members here. Remember, this is not a joint, it is an overlap. It is an overlap, not a joint. Remember, this is not a joint. See, you cannot see pin there. Not a joint. Right? Instead, it is overlap. Now see, I will put one more here. Here I will put this way. Here I will put this way. I will put one more support here. Okay. This also pin jointed plane frame only. But this also is stable. But later you will be knowing that this is a perfect frame. This also is a perfect frame. This is, I won't call it, but actually the people call it imperfect. But actually instead of imperfect, it is overstable, or it will be called redundant frame. This will be statically determinate. This also is statically determinate. This will be statically indeterminate. Later, these all you will learn when you go to structural analysis. Right now, not required. Just understand it little. Okay, now, further. Imagine, just imagine. See, just to understand, imagine. Y triangle, see, you make a note here. Y triangle is basic form for stability. For stability. See, suppose you have a triangle here. See, this way. This way. Imagine supports are not there. You spread like this on a plane. Then apply some loads. See, some loads you apply here. Anyway, what will happen? See, this will be stable. This load will be split up into two parts here. This will be split up into parts here. This will be stable. Nothing will happen here. Common sense, see, in triangle form. Okay, now, suppose you imagine a rectangle, 4 pins. See what happens. You apply some force here. See, support is there or not there. Okay, do one thing. Give a support also here. Okay, to give support. Some people tell supports are not there. Okay, here apply a force. See, supports are there. As you apply the force here, what will happen? See, immediately you can make out this is unstable. See, this is stable. This is stable. This is unstable. Because see, dotted line I will put here, initial position. If you put this way, what will happen now? See, if you apply load this way, this will start moving here. See, even this also will move. It will move that way. It will go outwards here. This will start moving somewhere here. See, all will become complete zigzag. See, it will fold. Or, see, it can't be stable. Imagine you make an arrangement. See, take one wooden piece here, wooden plank. One more wooden plank here. One more wooden plank here. Put pins. Apply loads at the joint whatever way you want. It will be stable. But if you take 4 wooden planks here, see, this way, overlapping I am not showing. This way you take it, overlapping will be there. Okay, dotted line not required. Put the pins. Apply some load. It will fold. Apply a load here, see. Apply a load here, it will fold inwards. Apply load here, it will go outwards. Apply load here, it will come inwards. Apply load here, it will go outwards. This is unstable. Or remember now, little later I will go for a term called perfect and imperfect. Perfect and imperfect. Imperfect. In imperfect, there is two terms are there. One is called deficient. Deficient. Other one is called redundant. Redundant. This comes under deficient. You make a note here. This will come under deficient. I will explain once again. Redundant, I already shown. Perfect also, I will show it now, everything by sketches, brief sketches. See. Okay. Before going further, don't see this one now. I will tell there are two types of, firstly, this should write all these you are right if you are interested. There are two types of pin jointed frames. I write here, don't see that one. That is, one is called perfect frames. Perfect frames. And other one is imperfect frames. Imperfect frames. Imperfect frames. See. Now make a note. A perfect frame consists of only basic triangles. See, this is here overlapping is there, no overlapping. See, only basic triangle, either one triangle or extended. See, one triangle here, one triangle, two, three triangles. Sufficient. Or you can make a note here, a perfect frame is one which satisfies the equation, which satisfies the expression or equation, anything, expression, n equal to 2j minus 3, where, right here, n is number of members, j is number of joint. Okay, now check here. Here n, number of members 3, see here 1, 2, 3. Number of joint 3. Therefore, here, if I consider, now do one thing. Now, before going further, before you write examples, do one thing. First, check how this equation came. So many people, if they ask question, they will, for a perfect frame, give the relation between n and j, or sometimes instead of n, people use m, members. People tell immediately n equal to j minus 3. How it came? Given in the book or told in the class. I will ask, okay, why can't you get it? How to get it? How to get it? Simple. See here. First observe. I am telling you how this expression came. N equal to j minus 3. Very, very simple. See here. First, consider one triangle. Just one triangle. Just one triangle. Triangle. Number of members. See. Okay, understood. Number of members is 3. Number of joint also 3. Now consider multiple triangles. Any number. Multiple triangles. Right here, any number. Any number. Okay, so let j be number of joints. J be, I will continue here now, number of joints. If j is the number of joints, see now correctly what I am continuing. Those who are serious, right here. If j is the number of joints, first skip first 3 joints. First 3 joints. Why? This case, see. First 3 joints. N equal to 3, j also equal to 3. Now, every additional joint, there will be 2 members. There will be 2 members. See here. Here, 1, 2, 3. Leave it now. You put one more joint here, see 2 more members. One more joint here, 2 more. Every additional joint will have 2 more members. So I'll write here now. See, I am not disturbing the board. How I dictate, that way you write. Okay, therefore, total number of members equal to total number of members equal to 3. 3 already over. For 3 joints, 3 member. So plus, see, total for when j equal to 3, n equal to 3. Now, let j is the actual number. So in the j, subtract 3. So plus n equal to j minus 3. First 3 joints, 3 members. Next further j minus 3 joint, each joint will have 2 members, or your n equal to 3 plus 2j minus 6, or n equal to, see here, 2j minus 3. See, n equal to 2j minus 3. When I first time told in a college, I won't tell, so many students told me, sir, so easy, sir. Yes. Why you are telling? Sir, actually I was taking for MTech class, master MTech class. They told, sir, in BE when you study, nobody told this, sir. What they told? Sir, they told 2j minus 3. If suppose we will ask, sir, why? This is an equation, rule. They told it is a rule. Maybe they thought thumb rule. It is not thumb rule. It is mathematical. Okay, now, leave it now. Start. Number of members 3. Check here, this joint. See what is 2j minus 3 here. 2j minus 3 is 2 into 3 minus 3. 2 into 3, 6. 6 minus 3 is 3. Oh, yes. N is 3. Satisfied, right here. Satisfied. Here. What is 2j minus 3? Calculate here. 2j minus 3 equal to 2 into 5 minus 3. 2 into 5 is 10. 10 minus 3 is how much? 10 minus 3 is 7. Oh, yes. N is 7. So, here n equal to 2j minus 3 is satisfied. Here also n equal to 2j minus 3 is satisfied. Therefore, these frames are perfect frames. See, I will put here figure 1, figure 2, then figure 3. Figure 3, I will put figure 3a, figure 3b to understand. Now write all these sketches, not earlier. Now write all these sketches. Okay, right here now. Therefore, n equal to 2j minus 3, right, is satisfied. Okay, proof I will remove it now. Okay, make more clear now. Okay, this also over, this also over. So here, this you call figure 3. Figure 3, you take figure 3a, figure 3b. This is figure 3a, figure 3b. Now, make a note first. A perfect frame will always satisfy the equation, see, perfect frame. Perfect frame means will satisfy the expression n equal to 2j minus 3. Whereas if n is not equal to 2j minus 3, it is called imperfect frame. Imperfect frame. But somehow, see, this is imperfect. But I don't like to use it because it is very stable. It is a very stable and strong. But what to do? Compared to basic, it is imperfect. It is an imperfect frame. So here now, see, this case, right? Right, this case, 3a. See, number of joints j. 1, 2, 3, 4. 4. Therefore, 2j minus 3 equal to 2 into 4. 2 into 4 is what? 8. 8 minus 3 is 5. Therefore, n, which is actually how much? only 4 members are there, is less than 2j minus 3, which is actually 5. That's why this is imperfect frame right here. Figure 3a is imperfect. Okay, right? Then further, here, number of members, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16. Number of joints, 8. Calculate 2j minus 3. 2 into 8 minus 3. 2 into 8, how much? 2 into 8 is 16, minus 3 is 13. Therefore, here n, which is 16, is more than 2j minus 3, which is 13. Therefore, this is also imperfect. Imperfect. Okay, now, make a note, this I told, n, therefore, this is what? This also is imperfect. Imperfect. Okay, now, further make a note. You should write, in case of imperfect frame, two subdivisions. 1, deficient frame, other is redundant. Redundant means excess. Deficient means shortage. Redundant means excess. So, write a note. I am dictating now. If n is equal to 2j minus 3, perfect frame. Okay, already I told 2 examples here. If n is not equal to 2j minus 3, either less or more, it is called imperfect frame. In imperfect frame, 2 types are these are example. Here n is less than 2j minus 3. Here n is more than 2j minus 3, or both the cases n is not equal to j minus 3. Now, if n is lesser, number of members are lesser, it is called deficient frame. Deficient means n less than 2j minus 3, that is shortage. Redundant means n more than 2j minus 3. Now do one thing, write one more note. Figure 3a is imperfect frame and deficient type. Why? 2j minus 3 will give you 5. Only 4 members are there. One shortage. Okay, here. This frame, right, figure 3, n is 16. 2j minus 3 is 13. So number of members are more than 2j minus 3. So it is imperfect frame with redundant, excess. Okay, now one last note. See, now everything is over now. I am going for analysis now. I don't want to waste time. See, come to figure 3a, right? 3a. Deficient, write a note. Deficient, how much deficient? See, 2j, see this here, 2j minus 3 is how much? 5. But actual number is only 4. So shortage. Deficient, one shortage. Put one member extra. Oh, suddenly now, number of joints is still equal to what? 4 only. But number of members will become 1, 2, 3, 4, 5. Now see, 2 into 4, 8. 8 minus 3 is 5. Now, n is equal to 2j minus 3. Now it becomes perfect. So, for a deficient frame, if you add member, you can make it perfect. Now see here. Here n is 16. 2j minus 3 is 13. See, n is 16. 2j minus 3, I already told, is 13. So, there is excess 3 members. Here, there is excess of 3 members. Excess 3 members. 3 members. That is imperfect, but what? Actually redundant. Now do one thing. Remove 3. See here. 1, 2, okay. Remove this one, 3. See what happens now. Remove 3. Now if you remove 3, now number of joint is still how much? 1, 2, 3, 4, 5, 6, 7, 8. 8. So 2j minus 3 equal to 2 into 8. 16 minus 3 is 13. Now number of members count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, 13. So for a deficient frame, see how much is the shortage. Add that much members so that triangles are formed. Very important. Triangles are formed. It becomes what? It becomes perfect. Then imperfect frame, redundant or what? Excess members are there. Over number of members. How much excess is there? Remove those excess. Once again, you will get back perfect frame. Okay, furthermore, I don't want to discuss now. First of all, these people, sometime I have seen, they discuss these things all more. But when it comes to important concept of equilibrium and apply method of joint and section, so many things are not told. And one more thing, there's a concept coming up later. Equilibrium. Majority of people, they will tell when you consider equilibrium of a joint, you are considering equilibrium of a joint under combined action of external and internal. No, wrong concept. I will tell it because they feel or they tell everywhere axial force, shear force, bending moment and torsional moment, section forces are internal. I will prove it later, wait for some time, it is external. I will prove it such a way that everybody who is telling internal will suddenly realize, yes, we are wrong. Not we alone are wrong. More than 99%. Okay, now, leave it now. Now I will go to analysis part. I think sufficient information. Those who are not serious, anyway, you have already gone up to here now. Those who studied came here. When you revise later, just to go through briefly, you make a note and study. Don't waste too much time studying all this now, because theory part. Okay, now I'll go to important, our what we call is equilibrium part or analysis using method of joint and method of sections. Now, before we proceed further to the most important part, see, 99% people, they want next part, method of joint, method of sections, the main purpose. Title you can see. First, understand briefly, very briefly. I wrote, see the title heading, Analysis of Statically Determinate Pin-Jointed Plane Frames. Then doubt will come. So, statically determinate and indeterminate, very seriously you discuss later when you go to shearing force and bending moment diagram, and furthermore seriously when you go to analysis of indeterminate structures in structural analysis. Right now, briefly, see, statically determinate pin-jointed frames and statically indeterminate pin-joint frames. One statement I will dictate you write. See, structures which can be analyzed by using only basic conditions of static equilibrium are called statically determinate structures. Then, structures which cannot be analyzed by using only basic conditions of static equilibrium are called statically indeterminate structures. You should write it. Now see, in case of pin-jointed frames and also later for rigid jointed frames, when you consider static determinacy or indeterminacy, there are two terms. One of them is external, one is external, other is internal. Internal too. For external, see, when you want to consider external, see, first consider external. Briefly I will tell, not too much because this is not the time. Purpose is to understand. External, consider support reactions. Support reactions. Now make a note here, one note. If you can find support reactions by using only basic conditions of static equilibrium, it is called statically determinate structure. Then number of unknown reactions should be equal to number of basic conditions of static equilibrium. Then one very important term is there, applicable. The term applicable I will discuss later. Right now not required. If number of unknowns is equal to number of equations, it is called determinate. And now right here, actions external. Consider support reaction. Note. If I told here, see, not here, see, statically determinate if equal, then write here, if you write it, number of unknown reactions are more than number of basic conditions of static equilibrium applicable, it is statically indeterminate. So number of unknowns should be equal, means determinate. If it is more, it is indeterminate. If it is less, it is called what? Unstable. Okay, now leave it. You consider 1, 2, 3 and 4. Briefly consider 1. See, one hinge, one roller. Now I will not tell how many reactions are there. Already told engineering mechanics so many times. Those who are not studied, it is their problem. See, A will have a vertical reaction VA, horizontal reaction HA. Sorry, I will not explain further. Here only one vertical reaction VB. So here, number of unknowns. When I am talking about X number, I am talking about external number of unknown reactions. I will tell N to understand, to save the time. I will put N equal to 3. Which one? VA, HA, VB. And number of basic conditions of static equilibrium applicable, I will tell E equal to 3. Which one? Sigma H equal to 0, sigma V equal to 0, sigma M equal to 0 for coplanar. Therefore, what happened here? Here, for figure number 1, your number of unknowns N is equal to number of equation E. Therefore, this is externally. First you copy the sketch, all 3 sketches. Then second round write. Therefore, right here, this one is externally determinate. Okay, now come to internal. Now I won't waste time. Reason I will tell you when I go to method of joint, or later when you go to higher knowledge or higher concepts. Right now I do not want to waste time. Internally, it is determinate if it is a perfect frame. Remember, if it is a perfect frame, it is determinate. If it is imperfect frame, if shortage is there, we are not bothered by unstable. If excess numbers are there, how many excess numbers are there? That much is indeterminacy, shortage. Remember that much. So here, see, make a note here. External. Come to internally. See, here, consider internal. You make a note here. This is a perfect frame. See, this is a perfect frame. It satisfies the equation n equal to 2j minus 3. You write all this one. Therefore, internally perfect. Therefore, it is one completely overall is statically determinate. Okay, sufficient. Come to 2. See here. Write first First consider here for figure 2. Okay, this I remove now. I want more space. I'll remove this one now. I want to discuss something else now. I won't waste time telling statement now. See here 2. First external. First consider external. External. See, mark here. One vertical reaction VA, horizontal reaction HA, here vertical reaction VB. Okay. External, number of unknowns are 3. 3. Number of equation also is 3. Why? Sigma M, sigma V, sigma H. So, your number of unknowns, the black I will put here, number of unknown equal number of equations. So, this figure 2 is externally determinate. Determinate. Okay. Leave it. Come to internal. We discuss 2. Internal. Right statement. This is imperfect frame or imperfect frame with the redundant. Excess number of members are there. See here. Here. Number of members. This is not determined. See. Number of members. This is not determined. Number of members. Okay. 1, 2, 3, 4, 5, 6. Number of joints is 4. So, your 2j minus 3 is 2 into 4 minus 3 is 5. So, number of members is more than 2j minus 3. That is, this is 5. This is what? This is 6. That is 5. Therefore, it has got one excess member. Or it is redundant. You will know later redundant. It is called first degree. First degree means redundant. Over. Therefore, you make a note here. Your 2 is what? Externally determinate. Internally indeterminate till first degree. Or overall combined together, you will know all these things later. Degree of static indeterminacy is summation of, you should write it, summation of external and internal. 0 plus 1. See why I am not telling, because this is not required now. Degree of but still I won't tell something. Degree of static indeterminacy overall is 1 because internally 1, externally 0. Okay. Now, come to 3. Little fast. 3. Figure number 3. Here. Externally. See here. Why figure number 3 is something? I want hinge here. Okay. I want hinge. Okay. That's why confusion. Okay. 3. Consider external. Go there. Mark reactions. 1, 2, 3, 4. Okay, right. VA, HA, VB, HP. Number of unknowns are 4. Number of equation is only 3. So your number of unknowns is more than number of equation. Unknown 4, equation 3, therefore excess of 1. So this is externally indeterminate to first degree. Come to internal. Right here. No. Oh, this is perfect frame. This is a perfect frame. Why perfect frame? Make a note. Number of joints are 1, 2, 3, 4, 5, 6. Number of joints are 6. Number of members are 1, 2, 3, 4, 5, 6, 7, 8, 9. 2j minus 3 is 2 into 6 minus 3 is 9 or n equal to 2j minus 3. Therefore, this is internally, it is determinate right here. Therefore, internally, this frame number 3 is internally determinate. Therefore, overall, it is statically indeterminate to first degree. Here, first the sketch I wrote earlier here, figure number 1 was completely determinate. Externally, internally, both determinate. Figure 2 is externally determinate, only 3 unknowns. Internally indeterminate, 2 first degree. Totally 1. Right 0, external 0, internal 1. Here. Externally 1, by 4 unknowns. You should not have more than 3 unknowns. So externally indeterminate to first degree, internally determinate. So overall also 1. This one is internal, that one is external. Now come to the last one over. With that one I stop this class. Because why? I do not want to start some concepts today because so many people are there. They won't see all these things. When they go to the class, as they go further, they will say, oh, theory. He is telling theories, not required for me. They will miss the most important. Therefore, introduction part 4, one more thing. Okay, so come to here, fourth one. See, here degree is 1, here degree is 1, it is internally, externally, 0. Here also degree is 1. Internally 0. Internally 0. Externally 1. External. See. Vertical reaction, horizontal reaction, vertical reaction, vertical reaction. Okay, I'll do one thing. I'll make this also hinge now. Okay, I'll make it hinge. So that little more work is there. Okay. Vertical, horizontal, right? Externally, one name you write. VA, HA, VB, VC, HE you write. 1, 2, 3, 4, 5. Externally, unknowns are 5. Equation is only 3. Therefore, your n is number of unknowns are more than number of equations. 3 equations, there are 5 unknowns are there. Therefore, externally, see, I am not explaining much indeterminate to second degree. I am not telling much because not required. This is not the way I teach. I will tell degree of indeterminacy is always equal to, I will tell you later when the time comes. First of all, these are only for information. Okay. So this is, remember, I told this fourth one is what? Externally 2. Externally 2. Okay. Internal, see there. Internal. Number of joints are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number of joints are 10. One more there. Multiplication. Number of joints are 10. More and more. We'll make more clear. Number of joints are 10. So your 2j minus 3 is 2 into 10 minus 2. 10 into 2 is 20 into 17. No point. Number of members equal to, see, our counting problem now. Be careful. This is internally 4th degree. I know it. By looking only I can tell. But for you to understand, okay, start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. It is 21. Therefore, number of members n, 21, is more than 2j minus 3, which is 17, or there are 4 excess. 4 excess. Or you can do one thing, remove the 4, it will become perfect frame. Therefore, internally it is fourth degree. Externally I told second degree. Internally fourth degree. So overall, this pin jointed frame is statically indeterminate to sixth degree. That is, see here. Externally 0, internally 1, so first degree. Externally 1, internally 0, therefore what? First degree once again. Externally 2, internally 4, the total altogether complete structure, because analysis means everything you require, it is indeterminate to 6 degrees. Okay, over. Now, before I am going to conclude the class today, before that one, there, see, for method of joints, in method of sections, which is coming up next class, there are some assumptions. I can't list everything. You can do one thing, you go to any textbook and see, they will put some 4 or 5. What comes to my mind, I will tell. Briefly, see. Assumptions are, all joints are pin jointed. Second one, there is no friction, or all joints are frictionless or smooth pin joints. Next assumption, loads are applied only at the joints. No load in between. This I will tell you next time. Then, in all members are subjected to only axial forces. There is no bending moment or shear force. See, still you don't know what is bending moment, what is shear force. Therefore, sufficient now. And all members are straight. No curved members. Curved members means problem will come. All members are straight. Apart from that one, if anything is there, I don't remember now. Okay, if anything is there, I will tell, or refer any textbook. What you do is, right, go to pin jointed frames. See the assumptions. They may give some 5-6 assumptions there. Write it. And when I prepare the notes, I will try to remember and write. Or maybe I won't refer a textbook, or I will keep on remembering what is missing like that. So, therefore, you don't require it. Okay, now we are ready for analysis of statically determinate pin jointed plane frames by method of sections and method of joints. That will start in the next class. That is, next class is very, very important, remember. So today's class only theory I told. I can as well see, if I am taking a class for engineering, academic class, these all I will finish, these all I will not tell for them. They don't require it. I may take some 15 minutes, that's all. But method of joints and sections very systematically. So now I'll conclude this today's class. Not much use for those who want to write examination, but those who want to get more knowledge, you understand all these things. Okay, we'll meet in the next class. Thank you.